Thanks everyone for coming to attend my presentation on this topic of service virtualization to make a native apps automation more solid, or we can say rock solid. So before I dive into my presentation, I want to introduce myself. So myself is Jagmit Singh. I'm a senior automation engineer at Innovapost. Innovapost, where I work, is a IT subsidiary of Canada Post group of companies. So I got, hopefully a lot of guys have heard about Canada Post. It's it's one of the uh, crown corporation in Canada which delivers parcels, letter mail, and all over the country. So yeah, so our is a Innova Post, which is deliver IT services and IT solutions to the Canada Post group of companies. Uh, so today I'm going to basically cover the agenda as you see in the slides here. So I'm going to first talk about what is testing in isolation is. So testing in isolation is applied to every domain of test automation. So it includes unit testing, API testing, or UI testing. It covers all different areas. So, but I'm going to talk about what is testing in isolation in general, and then I'm going to deep down specifically target the testing in isolation for native apps automation. So when I say native apps, I mean basically both Android and iOS, but specifically for my I'm going to target more specifically for Android automation. But this concept of testing isolation or is applied both for iOS automation also. And so, and in the next topic, I'm going to talk about the service virtualization. So, service virtualization is one of the means to achieve test isolation. And then particularly, I'm going to talk about API service virtualization. So, and then I'm going to talk about how to implement this service virtualization in native apps. So when I say implementation, like what tools I use to implement this virtualization, how do I implement it, what is basically the approach behind it. So I'm going to talk about all those things. And lastly, I want to talk about a CI/CD, so which includes service virtualization. So any projects in today's world in the test automation, you want to see how we can extend the scope of any new practice in CI/CD. So I'm going to demo how we include the service virtualization and CI/CD pipeline, like what processes to start before and what to end. There's a sequence you have to follow, basically to extend the scope of CI/CD and to include service virtualization. Okay, so this is more like a general definition of testing in isolation. So testing in isolation, it means that whatever test this is more to do with test automation, but whatever test you are testing, it should be logically isolated. What I mean the logically isolated is that means it should not be dependent on any other test or dependencies. So if there is any dependency on a test or any services, could be an API or databases, so all you want to achieve is that you want to basically either mock the service or virtualize the service. So the goal is basically you make your test reliable, because when you have removing the dependency on other systems or tests, with this removing dependency, you're basically making your test reliable and running in its own cocoon, basically. All right. And with this, you achieve so many other things: reliability, the flakiness, and the false positive, and all those things which you hear about a lot of times. So basically, you achieve all these goals with testing and isolation in practice. So as our focus is pretty much on automation, so I'm just basically with this, I'm going to basically uh, testing the isolation is applied to, as I said before, is applied to each layer of automation. So in testing pyramid, one of the major layers is unit testing, API testing, and end-to-end testing. So it doesn't mean that you can apply only to the top layer or API layer, unit level unit test. It applies to every layer, right? So when I say end applies to every layer, that let's for example talk about end to ends. So because it has dependency on an integration layer underneath. All right. So what you want to do is that you virtualize the integration layer so that which I'm going to talk in detail how to virtualize it. But the main thing is that you virtualize it in a sense that uh, what a response you're getting from integration layer or APIs is it like a definite response. It's also a reproducible responses. So same thing if you are writing an API test and the API test has dependency on other APIs. So maybe you want to virtualize those APIs. So you can have an API test which are dependent upon other APIs or a set of microservices, right? So that's also a dependency upon on the API test. So in the test isolation and in that model approach, what you want to do is that you basically virtualize those microservices also or API and APIs. So whatever you want to test that only. So basically all the other environmental, any outside dependency, you try to virtualize it, right? And same basically goes for unit testing. So unit test could have a dependency on other microservices or third-party services or the database, right? So what you do is that you apply the similar concept of virtualization and on mocking to basically virtualize the database or the APIs. So the concept is remains for all each level layer or test. It doesn't matter end to end or API testing, unit testing. You basically virtualize the underlying dependencies or any dependency on other components. So another term we use in our testing practice is that we call it testing as isolation as component level testing. So more elaborating it, whatever component, it could be an end-to-end or API is a component in itself. You are basically focusing your testing focusing your testing to test that component itself. So you're not worried about, or your focus is not to test other third-party components or the layers. So your focus is to basically test the component itself. So that's why we call it testing as isolation is also known as component level testing. So what we have seen working myself in industry for quite a number of years. So that's a common anti-pattern or what you call like a bad practice. I would say anti-pattern, not so you still call you can loosely can still call it a bad practice also. So too much focus on end-to-ends. When I say too much focus end to ends, what the management sometimes wants that you write from a tester like myself or other tester community is to write end to ends to basically cover the scenarios which should be either be covered the API test or unit test underneath. So they will say, okay, why not end-to-ends cover your API integration test or unit tests? For example, in my previous organization, I was writing end-to-ends to basically do the field validation. The field validation should be basically done at unit test level, right? Not end-to-end, but that's like an anti-pattern or people all they don't have expertise to write this or developers don't have time to write this. So there could be so many multiple reasons, but what I have seen in the industry that too much focus on writing end to end. Your end to ends are dependent upon the layers underneath. So what will happen is that it basically introduce more flakiness, slower execution, your test results are not reliable. There are so multiple issues that comes with too much writing focus on end to end, and especially when you have underlying dependency on other tests underneath. So talking about end-to-end in more specifically in the microservice architecture, because a lot of organizations are going towards this approach of having like a microservices-based architecture. Like um, in this, if you look at the in the slide here, so end-to-end, your test cases are dependent upon like layers of microservices, and one microservice could be dependent on other microservices, and this microservice is basically getting the data from a data store. So in any of the microservices, whenever you have see like instability on the in the microservices, for example, microservices being unstable or any instability basically cause your test case to fail. And what will happen? Like when the microservice is stable, you have make a more like a reliable test case. But if you any of the microservice is unstable, it causes the unreliable test cases. So you can what we call here is flakiness. Sometimes your test case pass and sometimes you fail because there's a dependency of underlying microservices. So any instability in a microservices basically cause you unreliability in the end-to-end test cases. So and that's basically end up in a flakiness in your test results. So flakiness is as bad as you can think. So talking about the flakiness in general, what happens that when the biggest advantage of flakiness in the UI test cases or in general any test cases, but what we have seen is flakiness is more pronounced in more prominent in the UI test cases and lack of confidence in your test cases. So what you this is it is a more like a comic diagram, a comic picture to explain what happens that when you see that all your test cases are failing. Why it's failing? Because let's say you one few of your microservices are down. So what happens? Your test gets more unreliable, cause flakiness in the test cases. So what is saying? Okay, what happens now? So as people who are dependent upon your test results, they have basically lack of confidence in your test cases. So and this is as I said, this is flakiness is more pronounced in the UI test cases. And going back to the topic, more specifically, I want to talk about the test isolation, how we can achieve that in a native apps automation. So basically, next few slides, I'm going to talk about specifically targeting the native apps automation, test isolation in that. So as you seen in a previous diagram, I was talking about a dependency of the end-to-ends, right, on the underlying microservices. So what you do in when you're talking about the test isolation, native apps automation, you try to remove the dependency on the microservices or API underneath. So how you do it, that's what I'm going to talk more in the next few slides and a demo later on. And so we're talking about the test isolation, right? And how to remove a dependency. So service virtualization is a step towards achieving this test isolation. Um, I'm more basically focusing here more on native apps, but this concept applies to basically everywhere. So I want to talk about what is service virtualization and how to implement that. When I say implement, what tools or practices or approaches we're going to use, follow for that. Um, and service virtualization is a broad topic. It could be you can be virtualizing your database, or you can be virtualizing so many other things. But focusing more here in our topic is I'm going to focus more about API service virtualization. So what is API virtualization is basically what you do is that you create a virtual copy of an API. So when I say virtual copy of API is basically mirror of your production API. And then once you create a copy of your production API, and then basically you sort of build an app where your app, instead of hitting your production or staging API, it hits the virtual service, right? And virtual service is basically a mirror copy of your production API. And then next step is that whatever responses you're expecting to get from a production API, your same responses you basically get from virtual service, and you play back those responses. So that's it. Does more or less explains what is a service virtualization. So basically, it's a mirror of, in a high level, as a mirror of your production API, which provides you the same feature set or same responses what you expect to basically try to expect to receive from a production API. Um, and how do you implement that? How do you implement that concept of the virtualization in the UI testing? That's sake. So as you see here, you on the right hand side you have production API, and that is basically communicating with your data store. What you do is that you create a virtual service that's more like a mirror of your production API. And And this virtual service basically provides the same response, is exactly as the production API, same response. So it's exact mirror of that. So here in your UI test cases is basically directing to the virtual service instead of production API. So yeah, so that's what basically you're getting the responses, same responses for your unit test from the virtual service instead of production API. And what benefits you basically achieve from this API server virtualization is that you have an access to a production API, which is a reliable, production like, sorry, let me say production like, it's not production. It's a production like API, which is reliable. Because reliable, because it's a copy of that, and whatever responses you want to expect to see in your test cases or test, it's always there. Because it's not dependent upon any services on thing. It's just an exact copy of that. And what you achieve with this, that you have a test results which are repeatable, and the sort of a false positives or the flakiness which you see in the regular end-to-ends. You don't see those type of issues or test results when you have a services which are virtualized. And another benefit which we see is that you can in a normal scenario which you don't have a where you don't have a virtualization in place, you a tester basically ends up waiting for the production service to be up and running and fully developed before he starts writing his test. uh, with implementing the service utilization, you can start your test early. How you do that? You can basically, if you know your test responses, or sorry, the API responses, you can build your virtual service beforehand, right? After chatting with like an API developer, as long you know the response, you can basically have a virtual service developed in parallel, or you can say, or before. And when you have a virtual service ready, or you have recorded these responses, you can build your test on top of basically of the virtual service. So basically, you have your test sort of basically developed early on, which is a major benefit app- especially when you have a test early on, not wait for the production service to be ready and then you build your test. Sorry, I have to take a break again. So 1, 2, 3, I start again. And how do I implement native as automation with the virtual service? So for example, in project, I use a tool called wiremock. I'm sure there are other tools in a community, and wiremock is one such open source tool. So using wiremock, what you do is that it helps you record the API response for a production service. And once you have recorded the API responses, what your app needed. So basically, you create sort of a store, or you can basically, this API responses are basically stored in the mapping files, what you call. It's more like a JSON files, right? I'm going to show you in our next slide. So you save all the responses what you need, record it, and you second, then you, in general, your app could be pointing to a production or a staging API, for example. Here, what we do is that we point our app to a virtual service. So to do that, basically, um, either you can basically tweak your config file or add a new config file where your app is pointing to the virtual service. And with a new config file, you rebuild your app. And after you have rebuilt your app, your automation test basically run against the rebuild app. In that app, but basically this app, you're pointing to a virtual service, not to a or not to a production. So that's how on a high level you implement the native ops automation with the virtual service underneath. This is more like our setup diagram. So as you see a production API on the right hand side, and then you have a wiremock server, which is it's like a proxy server, which helps you basically first record those API responses. And these API responses, as I said, this is saved as a mapping file in a JSON format. And then you basically, and your app now is pointing to this proxy server, or this is wiremock proxy servers, where it's redirecting the traffic to this responses which is recorded from the production API. You also have an option to basically edit the responses. In certain situations you want to um, edit the responses and play back certain other responses. So you have an option to do that. Next, I'm going to demo my implementation of the service virtualization for native batch automation. So, and I started a wiremock server. So this is the sort of the production API I'm trying to basically record the responses from. So what I do is that I point the base of that base URL of this production service, and now it's going in recording mode. So it's going to record the responses, which is directing to this production API. So what I do is that I go to the Postman, or I can send a request to the browser also, the same thing. So I go to Postman and send the request for the response I want to record. So I send the request, and here you see the response coming back, and it's basically exact the same response is recording. This wiremock is recording the response. So if you stop the recording, you can see the one mapping file created. So it has recorded this mapping file on this local drive. So this is one of the mapping file is recorded. And similarly, you can record other responses. So yeah, this is create a mapping folder, and it records the mapping file underneath. So when I refresh it, this is the new mapping file is created. So it is a GET request, and it's basically outputting the response which it get from the GET request. And next, in my app, this is an Android app. So what I do is that I create a new configuration file called, for example, wiremock.properties. So here I'm pointing to a wiremock server which is running on the local host. And what I do is that then I basically rebuild the app in a wiremock mode. As you see, this APK which I have built earlier, that's built with a wiremock mode, you can say, or a variant, right? Where the requests are pointing to a wiremock server. And this is my wiremock, which is running on my local host. Next, basically, I'm going to run this app. So what it's going to do is that I'm going to deploy this APK file on a simulator. And in so basically here open as a simulator. And for example, this request, right? This is, for example, one of the API track request associated with the pin. When I say track, this GET request is going to my wiremock server, which is running locally. So whatever response back you're getting from that is coming from that mapping file, which we had recorded earlier. Before that, there was a request to another API, which was not recorded. That's why it's giving an error message. So here, when you see it's a response, it came back from the wiremock server. So next, I'm going to talk about a CI/CD to include server virtualization. So so in any automation project, you want to see how any new concept, for example, this it's not exactly a new concept, but whatever concept of like server virtualization we want to have, how do you integrate with the CI/CD, CI/CD pipeline? Um, in my project, we used tools called Jenkins for CI/CD, but the concept can be applied for any other tool. For example, if you're using um, like Circle CI or yeah, Team City or any other tool, you can same concept can be applied. But I use Jenkins because I'm more familiar with Jenkins. So what we do in Jenkins is that first you build an app, right? You build an app where your API requests are pointing to a virtual service, right? And in the once you have built for example, in Android, it's .apk file. You build an APK file, which we can call it like um, wiremock flavor, right? Yeah, whatever name you want to give. And either you can archive the file, and once after you have archived the file, you push this app which you have built to a device. So in my case, it was a simulator, but that can be pushed to a real device also. So in our company, we just use emulators for most of our testing, but we can you can push it. You can have a CI/CD setup for real devices also. So what you do is that you push this app to a device. Here it's called we use emulators. And once you have after we have pushed this app to device, then you start your wiremock server. So wiremock server is basically, as you know, as a proxy server, which just shown you before, to support virtualization. So your traffic is now pointing to the wiremock server. So wiremock server can be running locally on your local host, or you can also Dockerize it, right? So in my next project we are trying to do is that we want to Dockerize this wiremock. So Dockerization has its own advantages. So you can just create a Docker image and push this Docker image to a Docker registry. And then you can, when you're running this wiremock Docker, you can just pull this image and run that wiremock in a Dockerization mode, right? So that's more helpful, especially when you're testing on a cloud setup. Yeah, this is something we're going to try next. But right now, what we are doing is that we are running the wiremock on a local host itself on a certain port. But and also you can have multiple wiremock servers running on different ports. If you want to, for example, um, uh, testing different apps, for example, where you need to point to another wiremock servers, you can have a wiremock server running on different port, and you can redirect your traffic point to a different ports. And then you basically start your Appium test. So here the Appium test is pointing to your virtual service because your app is pointing to virtual service. And when you start your test, the text execution happens where the API test is going to the virtual service. And once the test is complete, you kill your wiremock server and you kill your emitter, and then you can start your test on a next emulator. So that's how our pipeline works. CI/CD pipeline works with virtualization in place. This is my pipeline. So first, my first goal is to basically build an APK file for Android. So these are my command line options to basically build an APK file. So these are the shell commands. So once an app is built, I'm going to archive that APK file, which I'm going to push that to an emulator. And once this job is complete, I'm going to trigger the next job to basically run this Appium test on an emulator. And this is my job to run those Appium tests. Here, that's where I start this wiremock server running on the local host on this port 8090. And along with that, after I start a wiremock server, I start an emulator. Then I start an Appium test. So I'm using a tool called Catalog, which is built on top of Appium. So what this Appium test does, they push this APK file to an emulator and start the test. So when the test is complete, I kill the wiremock server, I kill the emulator. So here I'm going to start a build which basically triggers those the whole sequence of events. Yeah. So here you can see that is launched in emulator. Here I'm going to show you about the console log that shows up, and it's have launched this wiremock server and the emulator, and the APK file which we have built earlier on the previous job. So it's going to the Appium test. Are basically going to push those APK file on this emulator. This APK file, but as you know, is built with a virtual service underneath. So now the traffic is basically routing to this virtual service, where it is basically pointing to, you can call it like a point to the wiremock server. He is going to launch this APK file here. I'm just doing some cleanup before I launch this test. Yeah, this is the one of the tracking tests. It's a more like a GET request that we are tracking this like a package delivery information for associated with certain pin. So here the traffic is basically GET response is coming from this virtual service, not to a production service or a staging service. Yeah, so it's going to input this pin and this is going to get request is coming from the virtual service. So here it's got the response from the virtual service, and then you can validate the response which comes back is correct to your requirement or not. So that is pretty much my end of my presentation. I hope you guys enjoyed it and get some idea about the service virtualization in a broader scope of the things and its application for native apps automation.